Hello and welcome to this video brought to you by Smart Edu Hub Mumbai. Today's topic is Haber process. I shall teach you how to make ammonia using Haber process. And what is Haber process exactly? Why is it so important? Well, it was a process designed for the manufacture of ammonia by Fritz Haber, and millions of tons of ammonia are produced every year to make fertilizers, nitric acid, nylon, and explosives. So now you can understand the importance of the Haber process. Also, since it is an industrial process, we need to know what are the raw materials, what are the ideal condition of temperature, pressure, what are the catalysts, and how much percent of ammonia is really made under those conditions. Okay, so now let's begin with the first thing. So the first thing, as you can see here, is the raw materials. Now there are two raw materials that are needed. One is the hydrogen and second is the nitrogen. Now let us understand how to obtain hydrogen for the Haber process. Okay, the first way of obtaining hydrogen is from natural gas. It is obtained from natural gas by cracking ethane. So C2H6 gas gives you C2H4 gas plus H2 gas. So that means this is how you can obtain hydrogen by just simply cracking ethane. Okay, this is about the method of cracking ethane. Is there any other method of obtaining hydrogen? Yes, of course there is. And that method is by reacting steam with methane in the presence of nickel catalyst. That means methane, that is CH4, reacts with water, that is H2O gas. Gas I'm writing because it is steam now, in the presence of heat and nickel catalyst to give you CO2 gas and H2 gas. So there are two ways of making hydrogen, which is the raw material for the Haber process. Okay. Now that we are done with the preparation of the raw material hydrogen, let us see how to obtain nitrogen. Well, nitrogen is obtained by the fractional distillation of liquid air, as simple as that. And the fractional distillation of liquid air you must have learned when you began your organic chemistry lesson, sorry. Okay, so this is about the raw material, the sources of the raw materials. Remember, it's very important. There are questions based on the sources of raw materials. It's not only important to write that you need to use nitrogen and hydrogen, you also need to state the sources. Okay, so with this, now let's move ahead to the actual process of manufacturing ammonia. Okay, as you can see that all the blocks are just empty, we can't see anything, there's nothing basic, there's a plus sign, there are some arrows. So now let us understand what will come in between the plus sign. Well, obviously you know that you're going to use your raw material for the Haber process. So at one side of the plus sign you will have nitrogen, and that will be in one volume. So you will take one volume of nitrogen, and that one volume you will react with 3 volumes of hydrogen. Okay, now on their own they are very unreactive. If you want to make them react, then you need to compress them. So the first thing that you do to the gases is compress the gases. So nitrogen and hydrogen are compressed, and the volume is very important, the volume ratio. So 1:3 is the volume ratio of nitrogen is to hydrogen. Now, having compressed them, what next? Well, only compression won't convert them. You need to put them into a converter, because the converter will have the right conditions of temperature, pressure, and the catalyst. So after compressing, they are sent into another unit which is called as a converter. Now the converter contains iron catalyst, temperature 450 degrees Celsius, and a pressure of 200 atmospheres. So under these ideal conditions, nitrogen combines with hydrogen to form ammonia gas. So as you can see, the reaction has been written in the converter. and the iron catalyst is in the form of a fine powder. It's also important to note that under these conditions, you do not get 100% yield of ammonia. That is, although you are reacting a lot of nitrogen and hydrogen, only a particular percentage of it is getting converted into ammonia. So now let us see how much percent gets converted into ammonia. Okay, that's only 15%. So that 15% what you can see is the percentage that gets converted into ammonia. So obviously it means that 85% does not get converted into ammonia. So okay, now this ammonia on the top is a gas. You need to condense the gas. So obviously the next thing that you do is you send the gases into a cooling chamber. I'm using the word gases because now I'm referring to three gases: nitrogen, hydrogen, and ammonia. Because, like I said, only 15% of the gases get converted to ammonia. So the rest, 85%, are just nitrogen and hydrogen. So we have 15% leaving the chamber in another uh, outlet, and the 85% getting back into the converter. Now, why are they being sent back into the converter? Because we do not want to waste anything. Any which ways we'll be needing the resources, the raw materials, nitrogen, hydrogen. So it's better that we send them through another inlet into the converter. So what we do is we recycle the 85% nitrogen and hydrogen that are left unconverted, so that they get back into the converter and the process repeats again. So, like I told you, in the converter, ammonia gas is formed. When it passes through the cooling chamber, ammonia condenses, and whatever 15% of ammonia is formed, that gets separated through another outlet. So then that ammonia is collected and it is removed for whatever circulation, whatever use it is required. They are storing it and then sending it off to various people who are demanded for ammonia. So, or whatever orders have been placed for ammonia. So ideally, this is the entire process of manufacture of ammonia. It's very important to remember the volumes of nitrogen hydrogen taken 1:3. You need to understand that entire conversion happens in the converter unit, which contains the iron catalyst, 450 degrees Celsius, 200 atmospheres pressure. Just one reaction, N2 plus 3H2 gives you 2NH3. Remember, it's a reversible reaction. So I shall explain to you in depth why 450 degrees Celsius and 200 atm pressure is taken for manufacture of ammonia. Remember, it's a reversible process, so there are a lot of things going to affect the equilibrium. So please do watch my video when I'm explaining you the reasons why 450 degrees Celsius and 200 atm pressure is selected. Okay, then three gases remain because only 15% of the gases get converted to ammonia. So ammonia is first condensed by sending it into a condensing unit or a cooling chamber, and that 15% ammonia is removed from a separate outlet, and the 85% unreacted gases are then sent back into the converter. So this is the entire process. I have also done the summary, a quick summary, as you saw. So the best is to draw a flowchart the way I have drawn it and then keep explaining to yourself. If you keep doing that and keep learning these kind of industrial processes, whether it is Haber process or contact process or aluminum extraction or zinc extraction or whatever it is, all the industrial processes, if you keep revising once in a week, you do not get stressed out before the exams. Fine. So with this, I end my today's session on Haber process. I hope you like watching my video. Please do subscribe to my channel if you like. Thank you.